Good morning. Good morning to one and all. In this video, we are going to discuss about beams. I am Dr. Ganesh M, Associate Professor, Department of Aeronautical Engineering, Hindustan College of Engineering and Technology. Outline of this video: objective, types of beams and loads, shear force and bending moment, sign convention, shear force and bending moment diagram. What are beams? A structural member which is long when compared with its lateral dimension and subjected to transverse forces so applied as to induce bending of the member in an axial plane is called a beam. Objective: when a beam is loaded by forces or couples, stresses and strains are created throughout the interior of the beam. To determine the stresses and strain, the internal forces and internal couples that act on the cross section of the beam must be found. Beam types: types of beams depending on how they are supported. So here we have the various types of beams with different types of supports. First, we can see the cantilever beam with one end fixed, the other end is free. The second one is simply supported beam with both ends are simply supported. And third one is a beam with two simply supported, and over the support the length of the beam is extended. And the fourth one is continuous beam in which the support simply supported is more than 2. So here we have 4 simply supported beam, and the fifth one is fixed ended beam, on both ends of the beam is fixed. And sixth one, propped cantilever beam, in which one end is fixed and the other end is simply supported. Load types on beams. Types of loads acting on a beam. First one is concentrated or point load. So here at a particular point the load is acting on a beam. So here we have the example, W1 and W2 are the 2 point loads acting on a beam at a particular points. Second one, uniformly distributed load. Over the particular length of the beam, the load is uniformly distributed. Third one, uniformly varying load. Over the particular length of the beam, the load is uniformly varying from one end to other end. Concentrated moment. Similar to concentrated point load, at a particular point the moment is acting on a beam. Shear force and bending moment. So to analyze stress and strain of a beam, we need to find the internal forces and internal moments acting on a beam due to various loads. So to analyze the beam, shear force and bending moment are considered as internal forces and internal moments. The resultant of the stresses must be such as to maintain the equilibrium of the free body. The resultant of the stresses acting on the cross section can be reduced to a shear force and a bending moment. The stresses resultant in statically determined beams can be calculated from equation of equilibrium. Shear force. Shear force is defined as at any x section of a beam, the shear force F is the algebraic sum of all the lateral components of the forces acting on either side of this x section. So let us see an example of a overhanging beam. So here P1, P2, P3 are the 3 point loads acting on a beam. So in this beam, if you want to find the shear force at a section AA, so you can consider the forces, algebraic sum of the forces acting on the right side of the section AA, or the algebraic sum of the forces acting on the left side of the section AA. Similarly, we can find the bending moment at a particular point on a beam. Bending moment to be simply as the algebraic sum of the moment about an x section of all the forces acting on either side of the section. So here you can see the same example of overhanging beam with the 3 point load P1, P2, P3. So if you want to find the moment, bending moment at a section AA, so you need to find the moment of all the forces acting on the left side of the forces, or the moment due to forces on the right side of the section AA. Sign convention for the shear forces. So here we show the sign convention for the shear forces, whether shear forces is considered as positive or negative. So here the first diagram shows the positive shear force. In this case, if the upward forces acting on the right side of the beam and the downward forces acting on the left side of the beam, it will be considered as a positive shear force. Next one is negative shear force. If the downward forces acting on the right side of the beam and the upward forces acting on the left side of the beam, considered as a negative shear forces. Sign convention for the bending moment. So here we have the positive bending moment. So if clockwise moment is acting on the left side of the beam, and anti-clockwise moment acting on the right side of the beam is considered as a positive bending moment. Similar way, if the clockwise moment acting on the right side of the beam and then anti-clockwise moment acting on the left side of the beam will be considered as a negative bending moment. So positive bending moment is also called as sagging moment, and negative bending moment is also called as hogging moment. So simply we can remember as the smiley, which gives a positive bending moment, and the saddy will give the negative bending moment. This is the simple example you can consider for the remembering of sign convention for the bending moment. So shear force and bending moment diagram for various beams for various loads. If the load is acting as a point load, the shear force will be suddenly varying and the bending moment is linearly varying. If the load is uniformly distributed load, the shear force is linearly varying and the bending moment is parabolic varying. If the load is linearly varying, or for example uniformly varying load, the shear force is parabolic and the bending moment is cubic variation. In similar way, if the load is moment at a particular point, the shear force is constant and the bending moment is varying linearly. If there is no load between 2 points, the shear force is constant and the bending moment is linearly varying between the 2 points. If you have in the constant UDL load between the 2 points, the shear force is linearly varying and the bending moment is parabolic varying. Thank you for watching this video.